Till the last chapter, all we considered an object to be was a point object. Even a train was considered to be a point object. Now, we went on, we moved forward, and we saw an example where things were not point object because we moved things in a very small distance, in a very small space, and we got to see that things are more complex than what we consider till now. Things are not just point objects, So first thing we learned was center of mass. So with that, we'll be able to balance a pencil. We'll be able to make it move forward in a particular manner. And if anywhere else, if we hit an object, it has a peculiar behavior. So what else can you observe when I hit it at a point which is not through the center of mass? What other kind of things are we looking at? Right? Rotation stuff. So we're looking at motions which are not our traditional things that we have learned till now. So let me explain. We are going to start off with types of motion, overview. And yeah, till now we have looked at something called as translation motion. We are going to look at something called as pure rotation. And then the third one is the combination of translation and pure rotation. So there are three different classifications that I have as of now for you guys. You might find that classification of motion of rigid objects to be something else, as in the tree might look a bit different from books to books. But yeah, I think this makes sense for me and I put it across in this manner. So we are looking at types of motion. Under that, we have three different types. One is translation, pure rotation, and general plane, which is a combination of translation and pure rotation. So what is translation? Translation has no rotation is what I've written over here. Pure rotation has no translation. So what is translation? Well, let me give an example. This is an object. Can you guys please observe the object once? It's a rectangle in shape and it has an arrow. Now, if I have an object over here and it starts moving, say it moves in this manner. Okay, so it moves in this manner. Right? This is said to be rectilinear. Now I'll show you one more movement. Say it moves in this manner and then over here. And you guys have to point out the difference. I'm not telling what is what over here. So this is an example of curvilinear. Both are translation motion. While your rotation might look something like this. So for this, I need to actually redraw. Okay, so let me. Right, so this is said to be pure rotation. I have not written the heading, but this is an example of pure rotation. If I keep doing that, okay, so this is an example of pure rotation. Now, I have a question for you guys. Let me start off with this. What is the difference between the rectilinear and the curvilinear? What do you guys what do you see the differences? Okay, next. What do you see the difference between the rectilinear, curvilinear with pure rotation? You have your answer? So let me put it across to you guys now. See, rectilinear motion has to do with, if I consider any point on the object, it can be any point here or here or here. If I join the same point as and when the object moves, and if I connect those points, what do I get? Yes, I get a straight line. Can you see that? Again, you consider any point, I consider this point. It's over here again, here again, here again, here again. So this, if I join, see, it's set of straight lines. If I join the end of the arrow, set of straight lines. If I join the corners, set of straight lines. The same thing if I try doing it, let me take the tip of the arrow. If I try to do the same thing, what happens? Yes, it is a curve. Can you see that? It's a curve. That's why this is called as curvilinear. And that's why this is called as rectilinear. It forms a rectangle. Can you see that? If I join the points, right, they can form a rectangle. Okay, can you see that? So they form a rectangle. That's why this is rectilinear. Linear means straight. So what is the difference between curvilinear and pure rotation? Here in this two, the objects are always pointing in the same direction. Okay, so these are example of translation motion. So here the objects are always pointing in same direction. Unlike your pure rotation, where it keeps pointing in different direction. But here, the center of mass stays at one place. Okay, so that's the main difference. In rectilinear, you have the object to be pointing in the same direction. It can be I can have it this way also. Okay, but it has to be moving. It has to be moving. The entire thing has to be moving. So this is again an example of curvilinear. Okay, it can be pointing in any direction. Just that all of the points should continue to point in the same direction throughout. While in rotation, what happens? Pure rotation, the object stays there. It keeps going round and round. Example is what you guys can see around. What is the best example? A fan, right? Best example for pure rotation is fan. Okay, so this too is the difference between this translational motion and pure rotational motion has to be very clear. So let's read through. Translation motion has no rotation. The object orientation does not change. So under that we have rectilinear. All points moves along parallel straight lines. A car moving on a straight road. Curvilinear. All point moves along parallel curved paths. Example, projectile motion without spinning. If I throw something up, everything, it comes down up straight. It's difficult for me to explain over here. But yeah, this can be an example of projectile motion. Okay, the first three pictures over here. And pure rotation is rotation about a fixed axis. All points move in circular around a stationary axis. Example, ceiling fan spinning in place. Now, of course, in real life, we don't see just this two. It is a combination of translation plus rotation. Under this, there is one more general classification that I missed, wherein you have random movement. So it is these two are not random movement. I mean, these are movement, yes, but you can have one more classification that is random movement that I missed. Anyways, so we are looking at types of motion. There are three main types: translational, pure rotational, and translation plus rotation. So now we are looking at translation plus rotational, that is general plane motion. Under that we have something called as rolling with slipping and pure rolling. So this two we'll be studying this three basically: rotational, pure rotational, and rolling with slipping and pure rolling. Okay, so these are the three that we'll be concentrating on. The first two we are already covered, right? Your rectilinear and curvilinear we have already covered to the, including the last chapter. So we have directly, indirectly covered those. Now, what is this pure rotation and not this? And sliding. Actually, let me see if I can find it. So that was, oh yeah, this was for few seconds. It was example of pure rotational motion. Right, for a few seconds, that was pure rotational motion. The axis was fixed and the object was moving around it. Now rolling with slipping is what I'm trying to show. Right, the object slips and rolls also, right? So that is your rolling with slipping. Pure rolling, it might or it will look like this. So this is your types of rigid body. Let's just glance everything. So I could have used an arrow, that would have been better. So you can imagine an arrow up straight, not rotating at all. That's an example of rectilinear motion. Curvilinear, again, an arrow. Actually, let me try doing that. Let me put an arrow and try doing that. Okay, so again, types of motion, animation. By increasing the screen size. Yeah, so that is your rectilinear. Okay, you guys watch it. Okay, so you got to see the difference. So what did we see in the first one? Rectilinear. The arrow is pointing in one direction and the entire thing actually should have been up straight. That would have been more logical. Anyways, I just did this. So rectilinear, you guys understand. That is not a big deal. Curvilinear, do you guys understand? Can you see that? The arrow is pointing to the right and it continues to point to the right. It is moving along some curve and it continues to point in the right. So you can imagine the same thing for rectilinear, just that instead of a curved line, you can imagine a straight line. Now, we have pure rotation. In pure rotation, you can see the center of mass is fixed and things are moving around. Right? There's one axis that is fixed. Actually, need not be center of mass. There's one axis that is fixed and things are moving around that. And then we have rolling with slipping. So object rolls and also slips. This is not a great example. I tried to introduce small bit of slipping, but I don't know if you can see that. This is pure rolling. I'll explain the difference. It's an example of pure rolling. Okay. So I was looking at which one I have to explain you guys, rolling with slipping and pure rolling, right? And yeah, guys, for this example, I took center of mass stays at one place. Need not be center of mass only. It can be a fixed axis. The axis stays at one place. So I should make it clear. That time it was convenient to tell because I already kind of drawn it. The axis stays at the same place. Now, rolling with slipping, what does it mean? Or let me explain pure rolling. See, in pure rolling, right guys? So the amount of roll and the amount of it going forward, they match. Okay, so let me put the math over here for you guys. So if I have an object which rotates for an angle of theta and the radius is r of this object, Okay, if this is the case, then the distance traveled can be equated to theta times of r. Okay, so theta is your rotational angle in radians. So this is your angle, rotational angle in radians. Okay, so rotational angle in radians. So this is the case. This is for pure rolling. So the amount of roll that you get to see will reflect the distance traveled. Okay. So for rolling with slipping, so you can make sense out of it. So you are slipping means what? You're not rotating. You're just moving forward like you're doing in your translational motion. So here, distance traveled will not be equal to theta times of r. As simple as that. Okay, you got the difference? Pure rolling, if you roll, you move forward. Done deal. No other discussion. Rolling with slipping, sometimes you just might go forward by slipping while you're not rolling at all. So that happens when you have wet floor or icy floor and stuff like that, right? So that's that. Okay, so that is a small bit of introduction to your types of motion. So I would want you guys to make a note of everything. Try to draw as much as possible. So now I'll show you guys the drawing that I have done. Then the third part. And then the corresponding drawing that I have for you guys. Okay, let's start with the rolling motions.